Okay, guys, we're going to go ahead and start talking about your Chapter 5 test review. And a lot of this on the review is just basic definitions, but some of them need a little bit more explanation. So we're just going to go over it together. Now, let's start with number 1. Number 1 says, in his periodic table, Mendeleev did not always list the elements in order of increasing atomic masses. He normally did this, but not always. Now, because he did this because he wanted the groups of elements with similar, and it should be properties, together. Remember that the periodic table, even Mendeleev's, was organized by properties. Now, number 2, it says the discovery of the noble gases changed Mendeleev's periodic table by adding a, it would be C, group. They're adding a group because obviously we have those new elements. They have all the same properties, so they go in the same group. Number 3, Moseley discovered the elements with similar properties occurred at regular intervals when the elements were arranged in order of increasing, remember Moseley was atomic number, so it would be D. Number 4, within the p-block element groups, the elements at the top of the table blank than those at the bottom of the table. Now, when we're looking at the p-block, remember that the p-block is right over here. And remember that the p-block is broken up by our stair step. And remember that that stair step represents metals and non-metals. Okay, the metals are over here, non-metals are over there. So when looking at the top, the elements on the top are relatively, they are more non-metal, so that they are less metallic. Okay, because the majority of the guys up here are non-metals, so they're going to be less metallic. So the correct answer would be D. Okay, moving on to number 5. It says within a group of elements, as the atomic number increases, the atomic radius. Remember that atomic radius will increase as we go down a group or left across the periodic table. So we'll take our first group for instance. So we increase the number in the group. We go from 3 to 11 to 19 to 17 or to 37 to 55, and we see we increase atomic number, so the atomic radius is going to generally increase. The answer is A. Okay, number 6. It says for each successive electron removed from an atom, the ionization energy, and the answer would be A, increase. Okay. The ionization energy, remember, is the amount of energy required to take an electron away from a neutral atom. So basically what it's saying is that it's as we remove one electron and then we want to go back and remove another one, well, it's going to require even more energy than the first one. Okay? So the more electrons you take off, the harder it is to remove those electrons. Okay, number 7. Says the most characteristic property of the noble gases is that they are, and it should be D, largely unreactive. Every time we see noble gases, we think unreactive. Okay, 8, it says the number of valence electrons for group 2 elements. Okay, remember that our valence electrons, we know them by group because group 1 has 1 and group 2 has 2. Now don't forget these guys over here. Remember that group 13, we take away the 1 and it's 3, 4, 5, 6, 7, and 8. So remember your valence electrons. Okay. Number 9, it's the fill in the blank section. It says the elements with the atomic numbers from 57 through 71 in the periodic table are called. So we look at these guys down here. This is 57 through 71 at the bottom. And we know that these guys are going to be the lanthanides. Okay, that's your lanthanide series. Now, number 10, it says since the first energy level contains only the 1s sublevel, the number of electron or elements in this period is, so in the first period we're looking, we have 1, 2 elements. So 2 is your answer. Okay guys, number 11, it says the electron configuration of an element is, and we see this in noble gas notation, it's AR 3D10 4s2 4p5. Okay, now when we're looking at this, it's written a little bit differently than how we did it in class, but it's still the noble gas notation. And we know that it's going to end in p block, so I put the wide version up here because that's what we usually do electron configurations with. Okay, and we know that it's going to end in p block because it ends with 4p. So we're in the fourth period, and it's 4p, 1, 2, 3, 4, and 5, and that means it's bromine, and all it's asking for is it says the element is in the blank period, so we know that it is in the fourth period. If it ends with 4p, that 4 tells us it's in the fourth period. Moving on to number 12. Number 12 says elements whose atoms contain partially filled d sublevels are called. Remember that the D block are the guys right here. So we know that this is the D block, and these are also known as the transition elements or the transition metals. Okay, moving on to number 13. Number 13 says for elements in group 1, 2, and 18, the increase in atomic number for successive elements follows a pattern of 8, 8, 18, 18. So we look here and we see that between helium and neon, it's 8 protons. From neon to argon, it's 8 protons. From argon to krypton, it's 18. Krypton to xenon, is 18. And then from xenon to radon is 30. Now on to number 14. It says the electrons available to be gained, lost, or shared in the formation of chemical compounds are called valence electrons. Those are the guys, remember they're at the top of each group, and those are the guys that make chemical reactions possible. So valence electrons are really important. Number 15, it says the energy change when an electron is acquired by a neutral atom is called electron affinity of an atom. Okay, electron affinity is when a neutral atom gains an electron. 16, the measure of the ability of an atom in a chemical compound to attract electrons is called, and the main thing in there, chemical compound. Okay, whenever you see chemical compound and you're talking about electrons, that's electronegativity. 17, the energy required to remove an electron from an atom is called ionization energy. Okay, ionization energy is like the exact opposite of electron affinity. Electron affinity, we add an electron. Ionization energy, we take an electron away. Okay, 18 says the valence electron configuration for group 16 element in the third period is. Right, so we're just looking for the valence electrons. The group 16, so we're talking about groups are the columns, remember, up and down, and the third period, so 1, 2, 3. Okay, so where those guys intersect, that is sulfur. Okay, so we go ahead and write the electron configuration for sulfur and just the valence electrons. We know the entire electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Okay, and we know that the valence electrons are the electrons in the outermost energy level. So the outermost energy level is 3. So we add those up. 2 plus 4 is 6. That's our 6 valence electrons. That's our valence electron configuration. Number 19, it says 1/2 the distance between the nucleus of an identical atom that are bonded together is called atomic radius. Okay, atomic radius is the size of the atom. Okay, it's very important to know that. And remember that our atomic radius increases as we go down and as we go left on the periodic table. Okay, to go back and talk again, let's talk a little bit about 15, 16, and 17 because I forgot to add this. But remember, electron affinity increases as we move to the right and as we move up. And the same with electronegativity and the same with ionization energy. Okay, they're all trying to get to this point right here, and we know that atomic radius is opposite of that, and it's trying to go way down 20. There. An atom or a group of atoms that has a positive or negative charge is called an ion. The short answers, number 21 says, list the group, period, and block in which the element with the electron configuration of, it gives us and tells us that it is, move this down a little bit, we see we have our noble gas notation, so Rn, which is radon, and 7s1, so radon and then 7s1, so, and we know that that is francium, and francium is in the first group, 7th period, and it is in the S block. Remember, we have S over here, D in the middle, P over here, and then F on the bottom. All right, moving on to 22. Says, how do the properties of transition elements compare with those of the alkaline or alkali and the alkaline earth metals? The main thing that the transition metals, remember that your alkali metals are right there, and then your alkaline earth metals are right here, and then we have our transition metals right in the middle. The main thing that these guys have in common is that they are all three metals. Okay, moving on to 23. It says, of the following element, which has the largest atomic radius? So we're dealing with sodium and magnesium and phosphorus and chlorine. And guys, remember that atomic radius increases as we move down and as we move left on the periodic table. So the largest is going to be sodium. Number 24, it says, describe the general trends in ionization energy down a group and across the periods. So when we're dealing with ionization energy, it increases as we move to the right and as we go up. Now when it says down the group, so if we were going down the group, so we'll take this group, going down it, we know that that would be decreasing. So because increasing is going up, decreasing is going down. And then across the period, so this is going across, that means from left to right, we would be increasing because we know that it increases to 26. It says state the periodic law. And remember that on the periodic table, the periodic law just says that it that the similarities and properties of elements occur periodically, meaning that the elements in the same columns have the same type of properties and they occur periodically, and that's where we get periodic table from. 27, it says, how do the size of cations and anions compare with the size of neutral atoms from which they are formed? Whenever we have a cation, meaning we give up an electron, it always becomes smaller, and an anion, when it takes an electron, it always becomes bigger. All right, moving on to the back and the matching. Number 28, the main group elements are going to be the elements from the S block and the P block, so that would be C. 29, the lanthanide and actinide series are B, elements that make up the F block. 30, it says transition metals are E, the entire set of D block. And 31, the alkali metals are A, group 1 elements right here. And then 32, the halogens are D, group 17 elements. Oop, 17's right here. Okay guys, that is it for the review. I am going to do one special thing for you. I'm going to give you some bonus on the test tomorrow, but I'm only going to give bonus to the people who watch the video. So what we're going to do for the bonus on your Scantron tomorrow, we're going to be working on the back part. And the very top part where you write your name, what I'm going to do is I'm going to write a family on the board. Like I'm going to write either the alkali metals, the alkaline earth metals, the halogens, or the noble gases. And I'm going to write one of those families on the board, and all I want you to do is just on the green part of your Scantron, write down all the elements in that group. So if in your class I tell you, hey, you know what, I just write alkali metals on the board on your Scantron, I'm not going to say any more than that. I'm just going to say alkali metals, and I'll write it on the board. You write down hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. You write that down on, if I put that group up for your class period, you write those elements down, I'll give you 5 bonus points on your test.